of the Atlantic to the other side was quite an expedition, right? They had to be on the other side of the Atlantic, right, as far away as they could, but still be in French territory, because it's Cassini who did this, right? Okay, and so they did the measurement, and then don't you have to have a clock? Don't you have to know what time it is? Yeah, it's crazy, right? So you've got to have a clock. You've got to start it. It's got to run true for a long period of time, right? Or I'm not exactly sure how they did that. It's also possible to know that you are in Cayenne and figure out from noon your time exactly what time it is. You're right in France if you know that position, right? Because here's a tricky thing navigating, right? It's really easy on a ship to measure your latitude. All you have to do is find the sun at high noon, or you can do it any time of day if you're clever enough, right? But at high noon, you find the sun. Its elevation above the horizon has to do with your latitude, yes? Okay? But figuring out longitude, right, as you cross over, you're going across here, you're going like this. Figuring out longitude is crazy, right? The farther you go this way, the more the sun appears to be that way. But you have to look at it at noon. And when's noon? Well, noon's when the sun's directly overhead, but wait. Right? So that's the trick. You've got to have a timepiece in order to measure your longitude accurately. You have to have a timepiece that's accurate, right? Now this is tricky, right? Do pendulum clocks work on boats? Yeah, not so much. You have to have a modern timepiece, a chronograph, right? Columbus did not have such a thing. He just did dead reckoning. He measured the ship's speed and charted the progress on a map, and then figured it out from there. That's called dead reckoning, right? But now modern sailors they have accurate timepieces, and they even have GPS, right? There you go, right? Which sort of, kind of in a funny way, uses time as well, right? You're just measuring the time it takes for the signal to get to you from the, right? So it's a really accurate timepiece, right? Okay, so they measure this. Now we know how far away Mars is. Now, if you recall, don't we have a relationship between the radiuses? This is Kepler's law, isn't it? Okay, so we have a relationship between the radii and the period, and then we also know that radius of Mars's orbit minus radius of Earth's orbit, right, is something, right? We figured that out. They just figured out that. So we've got one equation. We've got two equations, and we know the periods, and we know this. Isn't that enough to figure out the, yeah? Yeah, there we go. So this is, by the way, a very crude way to figure out how far away Mars is. There are better ways, okay? But yeah, I just found this article. Obviously, I searched for Mars, Earth, and Cayenne. Giovanni Domenico Cassini. Right. So now you figure this out. We can. This is the earliest calculation of Earth's orbit. The accurate ones, really accurate ones, they actually have to look at how long it takes Venus to when it cuts across the sun's face. It's called a transit, right? Sometimes Venus will actually block the sun, right? And I think they look at the transits of Venus to figure this out, but I don't know how exactly that works, right? What? No, you actually just look at the sun with a proper solar filter, right? And then just actually track. You time how long it takes to cross a little bit of the sun, right? And then from that, they can figure it out. I don't know how. But you guys are all talented and gifted, right? So you could go figure out, just type transit of Venus and Earth-Sun distance into Google. I bet you'll find how to do it. Yes, sir?
Did the Cassini expedition work?
Yeah, it actually worked. Despite all odds, some of these things where they go to a special place to measure like solar eclipses and stuff like that, those didn't historically. Some of them didn't work, or they brought the wrong telescope in one case. Oops! No. Dang it! Months. Dang it! I forgot the lens adapter. Right? Okay. So this is the astronomical unit, courtesy of Kepler, Heresy, and Galileo. And everybody asks me who Heresy is. Galileo's younger brother. We don't capitalize his name because we don't speak of him, right? And his name later became synonymous with actual heresy. right? Well, he said that the Earth rotated and then went around the sun, right? And yeah, well, Copernicus said that, but Galileo made a big deal about it. Was friends with the Pope, wouldn't back down. He was not really good at politics, right? He wasn't good at saying whatever, you know. No, the Earth sits still and does not rotate. Okay, whatever. I'll keep doing what I'm doing. Just don't mess with me. Right? So this is our first thing. Let's try a little whiteboard. 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 Now, whether you use let's not throw the pens because the caps break and fall off. Whoops. I think I'm doing light years. Now, whether you use 1.496 or 1.5 is just, you know, basically to measure how devil may care you are, right? You know? 1.5 gives you kind of a jaunty devil may care sort of, you know, really doesn't make any difference on the accuracy of the things we're. So you're going to use, what are we going to use? I think you're going to use this guy, right? Yeah? An astronomical unit. This is one astronomical unit, right? I think you're going to divide, is my impression. Yes, yes. Yeah. Oh, no, you're not waving to me. You're communicating numbers. Do it in binary. What is it in binary? That's right, that's right. That's right. This is 1. This is 2. 2's a little dodgy. 3. That's right. 4. 4 looks dodgy. 5. 6. Whoops, wait. 5. 6. 7. 8. 9, that's right. 10. That's right. 11. 12. 13. 14. 15. How do you do 30? Show me 30. There he is. Yeah, that's right. So let me just show you this, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so when surfers are doing that, right, they're really going 9. 9. Right? But 10 would be.
Are there any notes that aren't in the worksheet that I need?
Me? I don't think so. Has everybody successfully divided? All right, next one. Oh, hey, there's no more whiteboards. Okay, so the next one is parsecs, right? And this is. Do they still have stars? Like students today aren't ready for sex? No. Not anymore. That's so sad.
In like middle school they did.
Yeah. But anyway, I used to say, you can use thumbs, yeah. Okay. Guys, I can either teach this to you, in which case you need to be quiet, right? Or not, you know. We used to have stars, right? And then, you know, students today aren't ready for sex. But this was the only sex, really, that they were ready for. I do believe parsecs, right? And then that, of course, led to the whole parsecs things up there. And then